In space, spinning isn't optional, it's the law. From a tiny tumbling space rock to a giant cluster of stars, everything in our universe has to spin. In fact, according to every rule of physics we know, a galaxy has to rotate just to survive. That spin is the cosmic glue that builds its shape, fights the crushing pull of gravity, and creates the beautiful spiral arms where new stars and planets are born. If a galaxy stops spinning, it literally shuts down. But when the James Webb Space Telescope pointed its high-tech infrared eye toward the deepest corners of time, it spotted something that shouldn't exist. Deep in the ancient universe, it found a colossal galaxy packed with billions of stars that had completely stopped spinning. It was standing perfectly still, frozen in time like a cosmic ghost. To space scientists, this makes absolutely no sense. It's like discovering a massive, rushing river where the water completely refuses to flow. To understand why a galaxy standing perfectly still is such a huge deal, you have to look at how these massive space structures are actually born. In our universe, moving around isn't just something stars do for fun, it's an absolute requirement of being born. Think about a figure skater doing a spin on ice. When they want to spin faster, what do? They tuck their arms tightly into their body. The smaller and more compact they get, the faster they go. In physics, this is a basic rule called the conservation of angular momentum. Way back at the beginning of cosmic history, the entire universe had to follow this exact same rule. Galaxies didn't just casually decide to start spinning one day, they were forced into it by nature. When the universe was super young, it was filled with gigantic, messy clouds of cold hydrogen gas and invisible dark matter. Gravity started pulling these huge clouds inward to build the very first galaxies. Because the gas particles already had tiny random movements as they fell, that motion got amplified as everything packed closer together. The gas cloud had no choice but to start spinning, flattening out into a wide, rotating disk, like a giant cosmic whirlpool of light. This constant rotation is the only reason galaxies don't instantly collapse. The spin creates an outward push, centripetal force that fights back against the crushing inward pull of gravity. This keeps the whole system stable, giving gas clouds enough peace and quiet to cool down and spark into billions of stars over millions of years. If a young galaxy doesn't spin, gravity wins the tug of war, dragging all that matter inward into a catastrophic, messy crunch. According to every space simulation we've ever run, finding a massive, fully grown galaxy that isn't spinning is like spinning a toy top on a table and watching it stay perfectly upright while completely stationary. It totally breaks the cosmic blueprint. Yet, that is exactly what the James Webb Space Telescope spotted. While scanning the ancient universe during a space survey, astronomers pointed Webb at an absolute monster galaxy named XMMVID 12075. We are seeing this galaxy as it looked when the universe was less than 2 billion years old. It was already dead, meaning it had lived fast and completely stopped making new stars. But scientists assumed that beneath its calm exterior, it was still spinning at high speeds, like everything else. To check a galaxy's spin from billions of light years away, Webb looks at star colors. If a galaxy rotates, stars on one side move toward us, shifting their light to a blue color, while stars on the other side move away, shifting to red. But when the data for this galaxy came in, there was no blue side and no red side. The stars weren't orbiting in a neat circle at all. Instead, billions of stars were flying around in totally random, chaotic directions, buzzing past each other like a swarm of angry hornets. The galaxy had zero overall spin. It was just sitting there, dead in the water. How did this giant lose its momentum so early in time? In the next chapter, we are going to look at the ultimate cosmic car crash, a head-on collision that stopped a galaxy dead in its tracks. When a massive mystery happens in deep space, scientists have to act like detectives looking at a high-speed car crash. They examine the leftover debris and the angles of the wreckage to figure out exactly what broke the machine. Right now, the number one theory for how a galaxy can completely lose its spin so early in time is a process of brutal mathematical cancellation, a perfect cosmic head-on collision. We know that galaxies in the early universe didn't live alone in the dark. Because the cosmos was much smaller and more crowded back then, galaxies were packed tightly together, constantly pulled around by the heavy gravitational highways of the space web. Because of this, space collisions were a daily routine. Usually, when two galaxies crash, they merge to form an even bigger, faster spinning system. But every once in a while, the universe sets up a rare scenario of total mechanical destruction. Think of two identical toy spinning tops sliding across a table. If they hit each other at a random angle, they will just bounce off and keep on spinning. But what happens if you launch them so they crash into each other perfectly head-on and they are spinning in completely opposite directions? Something incredible happens. The clockwise spin of the first top directly fights the counterclockwise spin of the second top. At the exact second they slam together, the two opposite forces grind to a halt, transfer their energy, and completely cancel each other out. Both tops stop dead in their tracks, losing all their spin instantly. This is exactly what astronomers believe happened to our mysterious stationary galaxy. Billions of years ago, it wasn't just one dead giant. It was likely two vibrant, fast-spinning spiral galaxies rushing through the early cosmic dawn. By a stroke of crazy cosmic luck, they lined up on a direct, face-to-face collision course. Because their internal space whirlpools were rotating in opposite directions, the crash didn't spin the new galaxy up. Instead, the collision acted like a massive, invisible brake. The momentum of billions of stars clashing head-on violently wiped each other out, scrambling their neat circular orbits and leaving behind a chaotic, non-spinning mound of star debris. But a crash like this does way more than just stop the spin. It triggers a violent chain reaction that completely ruins the life cycle of the galaxy. When two giant disks smash together, the huge clouds of cold hydrogen gas inside them can't just pass through each other like stars do. Gas creates friction. The gas clouds violently slam into one another, compress, and experience a massive shock wave that causes them to rapidly cave in under their own weight. This sparks a colossal, hyper-aggressive burst of star-making known as a starburst. For a brief, brilliant period, the colliding system starts manufacturing millions of new suns, hundreds of times faster than our Milky Way. It is a spectacular, blinding finale. The galaxy essentially burns through almost its entire lifetime supply of fuel in a single, desperate flash. Once that flash is over, the galaxy is completely broke and out of raw materials. Without any cold hydrogen gas left to cool down and form new stars, the star factory shuts off forever. It becomes a quiescent, dead stellar graveyard. This perfectly explains why Webb found this stationary galaxy completely red and dead so early in the timeline. The exact same crash that murdered its motion also forced it to grow old and die at a terrifying, hyper-accelerated speed. However, as scientists looked even closer at Webb's data, they realized the math behind a simple collision didn't fully solve the case. Even a perfect crash should leave a little bit of spin on the outer edges. To stop a giant of this size so completely, something else had to be actively choking it from the deep interior. In our next and final chapter, we are going to look at the monster hiding in the central engine room, a supermassive black hole that went rogue and starved its own home galaxy to death. A massive head-on collision is an awesome explanation for how our stationary galaxy lost its spin. But according to the rules of space fluids, a crash should eventually settle down. Over hundreds of millions of years, leftover gas should slowly fall back toward the center, pick up a little bit of a swirl, and start making new stars again. To keep a galaxy completely dead, flat, and frozen in time, you need an active killer on the inside and an invisible anchor on the outside. Every massive galaxy houses a monster at its exact center, a supermassive black hole. Usually, these black holes sit quietly. But during a violent head-on crash, the central engine gets absolutely flooded with millions of tons of cold hydrogen gas. The black hole can't swallow it all at once. The trapped matter rubs together so violently that it heats up to billions of degrees, transforming the black hole into a blinding cosmic blowtorch called an active galactic nucleus, AGN. This is where the black hole turns on its own home. It shoots out colossal jets of pure radiation straight through the heart of the galaxy. This intense energy hits the surrounding gas and boils it to millions of degrees. For gas to form new stars, it has to be freezing cold. By heating it up, the black hole completely locks the star factory down. Even worse, the sheer physical pressure of the radiation jets acts like a massive space broom, literally sweeping the remaining gas completely out of the galaxy into the empty void. This process, called quasar quenching, leaves the galaxy completely broke, trapping the remaining billions of stars in a chaotic, non-rotating loop forever. But to hold this dead, non-spinning giant together against the extreme expansion of the early universe, you need one final piece of the puzzle, a massive invisible skeleton. You need dark matter. Dark matter is a mysterious, invisible substance that we can't see, but its immense gravity pulls on everything around it. In the early universe, dark matter built a giant, interconnected web of filaments that acted as the gravitational blueprint for the first galaxies. Every galaxy lives inside a giant bubble of this invisible stuff called a dark matter halo. Webb's discovery suggests that early in history, some of these invisible halos grew to an unnaturally massive, ultra-dense scale. If a young galaxy forms inside an unusually heavy, non-rotating dark matter halo, the invisible bubble acts like a giant physical anchor locked into the fabric of space. As the regular gas tries to spin, it gets violently dragged through this dense, stationary dark matter graveyard. The constant gravitational friction acts as a permanent brake, ruthlessly stealing the galaxy's rotation before its spin can ever truly develop. The James Webb Space Telescope has shown us that the early universe wasn't just a simple, slow-paced building project. It was a wild, highly volatile frontier where head-on crashes, black hole blowtorches, and dark matter anchors could completely freeze a galaxy's destiny in a heartbeat. We are children of the spin. Motion is our reality. But deep in the ancient dark, the universe built monuments to absolute stillness. Colossal, silent empires of old stars that stood perfectly still while the rest of the cosmos rushed past them. They are true time capsules from the dawn of creation, proving that the fabric of space still holds secrets powerful enough to completely rewrite our history among the stars.